time to start that.
Well, we'll give them like a minute or 30 seconds.
All right.
Had 65 registered. So
Oh, wow.
I know by me there was like freezing rain. So I don't know if
Yeah, the roads are crystally here too as well.
Mhm.
Though they have the salt trucks going by several times already.
Good morning, guys. If you want to open up your chat, we will be throwing in the handout there today. We will not be using poll EV. We will be using the Zoom polls. We'll go over that again.
So I guess as long as we're here, we may as well start, huh?
Right. Thank you guys for joining us. Today we have Jeff Scott teaching pavement management. If you want to go to the next slide. Like I said before, we can open up that chat pod. We will be putting the handout in there. If you have any questions or concerns, you can put them in the Q&A. If Jeff asks you to raise your hand, there's a little raise hand functions, kind of like a mini poll. Next one.
Next one.
For PDHs, only the person signed up for today's webinar will get the PDHs. All of the information will be in the email that we send out after the webinar. I think there's a few more bullets. There we go. If you are in another state, you have to check with your LTAP center to make sure it is PDH worthy. And I believe with that, I will turn it over to Jeff.
All right. I guess we'll do the starting here. Again, we're going to talk about today pavement management. I guess we'll start at the basics and go right to the Wikipedia definition, since we know the computer's always right. Pavement management definition by Wikipedia is essentially the process of planning the maintenance and repair of a network of roadways to optimize pavement conditions over the entire network. So we'll get into a lot more depth on that as we go. Some of the history, well, not necessarily history about pavement management. People have been doing pavement management or managing roads since roads began to begin. But part of the history as far as why it's gaining steam was back in 1999, the Government Accounting Standards Board, or GASB, issued a statement 34, which basically recommended government agencies to report the value of their infrastructure assets on their financial statements. They recommend basically that you would do this through a historical report for capitalized long-term capitalist assets. But as we all know, most local agencies don't really have a history going back too far in their records. So essentially they realized that, and they provided another method of doing that. And today we're going to be talking about some of that. One approach is depreciate assets over time. And the other one's a modified approach, which is what we're going to be talking about. That provides flexibility in reporting the value of the assets based on the use of a systematic defensible approach that accounts for the preservation of assets. Essentially, pavement management and pavement management systems provide the tools needed to evaluate your pavement assets and meet the GASB 34 requirements. Well, a little bit of management about that. But as I mentioned, pavement management, everyone has some sort of method of managing their road surfaces. Some are good, some may be not. It really depends on what works for you. But a pavement management system basically is a formal maintenance program that provides a systematic, consistent approach to evaluate the present condition of each of the pavements. From there, it determines the proper type of pavement maintenance to fix the distress and prevent the accelerated degradation from occurring. It helps prioritize necessary repairs, produces reports, uses its reports basically to identify or include overall conditions of the networks and what it might cost to return the entire network to an acceptable level of service. So there are other methods, as I mentioned. Everybody uses some sort. If you have a road and you're doing maintenance on it, you got some sort of planning or some sort of pavement maintenance program. Again, as I meant, might not be the best, but everyone uses some means of developing a road maintenance budget. Most don't follow a systematic method to make it cost effective, but these are some of the methods that are here. We've got last year's budget, which is essentially using the previous year's budget with arbitrary incremental increases or decreases, just to try to use it as a basis to grow on. And another one is the other one is the squeaky wheel, where budgets are developed by responding to emergency demands and citizen complaints. That one's pretty ineffective on getting ahead on the overall network. Another one's standard program. That's basically establishing a program based on periodic maintenance, such as seal coats every 5 years or overlays every 10 years. The worst first, which it seems like it might be a pretty logical thing. You're fixing that worst road and getting it fixed, and it seems like a logical approach. A lot of times the public and the board like that because now they see something being done. But in reality, it's not necessary. It's not necessarily the best way to go. And we'll talk about that coming up as well. The political pressure, basically using political considerations to establish a program and budget. I worked down in one agency, and that was the program. Every ward had to have a couple or 3 roads done on election year. One time it got just the beginning of November, they paved the road just before election time. It was cold, it was wet, pavement didn't really do very well. The first snow, they plowed it all back up. So it really isn't necessarily the best way to go about doing it. Then there's the gut feeling. This is based on the road manager's knowledge and experience and the gut feel they have as far as what needs to be done when it needs to be done. This is actually a pretty good way of doing it if you really know what your roads are doing, but that takes years and years of experience. But it is difficult to defend because now you're working off what you know and not necessarily something that's documentable. Some of the maintenance decisions, whether they're individually or in combination, may work if there's adequate funds. The system is in satisfactory condition. However, if it's in bad shape and getting worse at the same time that the funding sources are becoming scarce, and there's a push to lower taxes, there's a clear need for a better decision process based on reliable information. So in a tight fiscal environment, some of the questions you might want to ask yourself is, where should the maintenance on that road be focused? What will happen to our roads if maintenance funding is increased or decreased? What is the most cost-effective maintenance for each of the asset or each road segment that's out there? Again, that's all going to be depends. How can we spend funding in the most cost-effective way? And the other one, do we have a maintenance plan for the next 5 years? Do we know where we're going? Do we know what we want, what we expect? It is essential to be able to answer these questions because if you can, then pretty much you have an idea what's going on. So typically you're going to need in a management system that's going to assess the condition of the network, weigh the alternatives, establish long-term programs, and through that budgets as well. So with the decreasing amount of funds, it's going to be important to take an more effective approach, and that's hopefully what we're going to discuss here today. So under normal times, local municipalities owning and maintaining the majority of the roads in the state, funding is always an issue. As we all know, with materials going up and labor going up and finding people going down, it can be difficult. So in this slide here, the towns represents who owns what percentage of roads in New York State. Towns own 52%, the counties own 18%, cities 11%, and the villages own about 6% of the roadways. So by and large, a good majority of the roads that are out there are basically maintained and owned by the locals. The state owns approximately 13% of those entire state roadways, although the roads were larger and built for greater amounts of traffic. The locals still fund the more, you would say, the more links in between those state roads. So with 50% of the public funds spent on roadways, it tends to be the largest single cost for local governments. Add on the additional other important assets that some municipality needs to maintain, and the costs associated with it, and it's easy to see why funding can be an issue. So when we look at that, the source of funding or local taxes supports approximately 89% of the expenses needed to maintain our highway departments, PPWs. About 10% of the funds in those local roads comes from state sources, and about 1% come from the feds. Because it's our funds, our local funds, each and every one of us that pays taxes basically is supporting our local roads in some capacity. So it's important to look at these roads a little differently, try to be a little bit more efficient on how we spend that funding. So it could sound pretty complex, implementing a basic pavement management system, but it might be a little, I would say it's probably a little easier than you might think. Anybody setting up a pavement management system, they should attend some sort of pavement management systems training to properly understand and implement the pavement management system. But there are multiple levels of a pavement management system. First is a network level where you look at the entire network to analyze and determine which maintenance, repairs, and rehabilitations you're going to look to be funding. And the second is the project level. That's after you decided how your schedule is going to be, your work schedule is going to be for each year, your annual plans. We would look at each individual project that you've selected at that point and study it a lot more in detail. Try to determine what additional repairs might be necessary. Example maybe you've got a culvert that's rusted. You definitely want to replace that before you invest money into the surface. Maybe you've got manholes that are collapsing. You may probably want to investigate those, see if they need to be repaired or replaced. Maybe manhole covers have been buried in previous paving. Maybe you want to bring them up and lift them up to actually surface level. So there's other things involved when you're actually doing it at the project level. But at this case, we're going to look at the network level, kind of get an overall view of the entire network. The network management system is essentially, most municipalities have a lot of miles of roadway. Not all of them, some have 10, 15, 20. And most can't afford to do any in-depth analysis of each segment of the roadway due to the amount of time and the associated labor that goes along with it and the cost. So that's where a network level pavement management system comes in. Essentially, you want to collect the minimum amount of information that's going to be useful for you to support the analysis of the overall condition. And this information can be collected using machines, walking, windshield surveys. Really depends on how you want to do it. But some of the things that are involved are defining the limits, and this basically not the limits of the municipality, but the limits of each segment of the road. You want road segments that are manageable, that if you're going to do a repair on it or a paving project on it, you may not be able to do 24 miles of that road. So you need to break it into sections you can handle and manage. By doing that, you can actually evaluate those individual sections and give you a lot more information and identify any kind of issues that you might have, even if there's specific sections, maybe a low area where the ground is soft. So you want to break each of those longer roads into smaller segments by setting limits on where they are. You want to develop an inventory, basically find out what you have, conduct condition surveys, determine what the pavement distresses are, develop maintenance strategies, cost estimates, life expectancies, and then you want to determine the funding needs. Using an interactive process, you can select candidate projects, analyze the impacts of decisions on future conditions and funding. You can implement a feedback system, basically that's updating the cost and life expectancies. And maybe you want to revise your maintenance, repair, and rehabilitation strategies, something that may not work for you. Maybe you want to revise that. Or maybe there's a new practice coming up, maybe you want to use that. And the whole goal here is to improve the reliability of the system. And as I mentioned, the project level is a little bit more site specific. Once that repair has been selected and scheduled for maintenance, a closer look at the project site specific needs are evaluated. These can be incorporated into the project planning for the implementation. Again, this is referred to as project level. The network level is, as it says, is a network evaluation. Where it compares itself to itself, the project level focuses on one individual project at a time. So as I mentioned, everyone does some sort of pavement management system. Pavement systems, some sort of management system. A pavement management system is a planning tool used in the aid of pavement management decisions. Many of the pavement management software that's out there can actually model a variety of different things, future deterioration based on changes in traffic or weather conditions, and make recommendations based on those anticipated changes and variations in what's going on. Measurements can be said, as I mentioned, it can be physical ground inspection, the vehicle inspections from a moving vehicle. And they've also got automated sensors mounted to vehicles that can actually measure changes and cracks and all that kind of stuff from it riding inside a vehicle. Variety of different types of software that's out there. So essentially, some of the high-tech software, it's not only expensive, but it requires annual support for it. And a lot of them are really intense. So you almost need an individual person to work on that. They're time-consuming, labor intense. So a lot of the smaller municipalities really can't afford going with the high-tech systems. There's manual techniques. You can do this paper and pen. And then keep track and do that again. Doing some sort of pavement management system that's a little bit more in depth, something that's going to help you conduct some of the repairs and maintenance techniques. You want to do them basically. You want to do the right repair at the right place at the right time. So it's again, you're looking for the cost savings over just routine or time-based maintenance schedules. We've got the road deterioration. As with anything, as soon as you begin to use it, as soon as it's constructed, it begins to deteriorate. As you can see here, it goes from over time. Condition of a pavement is going to drop slowly. 75% of the time, you're going to get about a 40% drop in the quality of that pavement. Based on the loading, the more frequent loading, the greater stress on the pavement. Surface, subsurface drainage, freeze-thaw cycles, solar impacts that can impact the pavement, can over time cause that pavement to start to degrade. So once you've got to a certain point and the cracks start opening up and the problems start becoming a little bit more visual, moisture gets within that base, starts going through those cracks, softens the base. As the traffic continues going over it, it causes the base to flex, which causes the surface to flex, and that's where you start to get the cracks. Extremely soft, you'll start getting potholes, and as the more cracks, the greater the size of the cracks, the more moisture that gets in there, the greater and quicker the deterioration goes. So in this graph, you can see that there's a 40% drop over the last 17% of that time, and that's because the base is typically failing at that point. One thing to note, during that 75% of the time, each rehabilitation technique is about $1 per unit. Once you pass that 75% lifetime, rehabilitation and reconstruction will increase to 4 or 5 times that per unit. So the goal, again, try to keep those roads in good shape. And here's the worst parts. These are routine maintenance, the preventive maintenance, the corrective maintenance. Those are all the more affordable approaches. So when it comes to the worst first, you're letting that pavement fail, and then you're spending a lot of money to fix that pavement when over time you could have just done smaller repairs. I guess to visualize this, we've got this over here again, pavement condition over time, and you can see how the original pavement goes down through here. They reach a certain point before it gets at poor, and they do another treatment. Maybe it's a chip seal, maybe it's a slurry seal, maybe it's just crack sealing. And then a few more years to get out of it, and then they do another surface treatment or whatever it might be. And then the idea is basically to keep those roads in this good condition by doing these smaller work projects and spending, as I mentioned, you spend $1 per unit here on each of these, instead of 5 or 6 down here when you get to here. So just incrementally, you're spending $3, 3 units worth versus five times per unit here. So you get, again, more bang for the buck when you're using what material you have. As far as cost goes, preventive maintenance is just that. Maintenance utilized to prevent an asset from failing. In this case, that's pavements. By providing treatments to extend the life of an existing surface and prevent it from failing before it has a useful life. It's going to go a lot more. You're going to save a lot more money. If the surface and the base have not significantly deteriorated, relatively inexpensive treatments can be used to keep the water out of the pavement, prevent oxidation of the pavement, and keep and maintain good skid resistance on those roads. It also keeps those roads better looking. So over time, they're going to eventually fail, but carefully selecting a timely application of a treatment for maintenance can keep the road in very good conditions and extend that useful life. It's again, it's just another way of looking at it, but instead of fixing everything, rebuilding every time you do that. I like to correlate a lot of this sometimes to maybe having a roof leak. You got a leak in your roof. You don't want to wait till that leak gets so bad that you've got the ceilings falling out and your electrical boxes are rusting and you've got to completely rebuild inside the house. What you want to do is stop that leak at the roof, repair it, and keep everything below it dry. The same concept with a roadway too. The road, once that base gets wet, starts to destroy, the costs go way up. There's several tasks required when you maintain a top quality pavement inventory, again, with the goal of sustaining an overall condition at desirable levels of that network. Again, you'll use pavement preservation, but some of the steps that you need to do is basically collect an inventory, kind of find out what you need, do a condition assessment, find out what condition they're in, and then assign repairs. Analyze the network, basically do an analysis of all the roadway networks, see what you have, and then you're able to put prices to some of the costs, and from there you can start to determine what needs to be done, and then moving into the implementation phase. And then we'll talk about all these coming forward here. But the inventory, you need to know what you have, as I mentioned. Most agencies have an inventory. They're required to submit that to the DOT annually. And if you aren't aware of exactly what you have or what your inventory might be, you can look into the local highway inventory. That's basically maintained by the New York State DOT. In the past 10 years, they've used a lot of Google Maps and GIS and a variety of other techniques to basically map out and determine what the roads are in each agency. But in some places, particularly high growth areas, they have developments popping up in over time. Basically, they might take 2 or 3 years to build, but then those roads are turned over to municipality. And a lot of times the town boards don't necessarily, or the zoning boards or the planning boards, wherever they are, don't necessarily convey that information over to the DPW or the highway department. So going out and doing a physical inspection or checking on what the roads you have can be helpful. Essentially, it's been found through some of the agencies that some of the roads that they haven't been recorded on that local highway inventory. If it's incorrect, if you find there's roads that you don't have, let the state know. That's going to impact your CHIPS funding. And that's the important part. We need the funding. Again, as I mentioned, check for recent changes. But some of the items you're going to necessarily need in that inventory, things that don't necessarily change over time, are going to be the length and the width, surface type, maybe the number of lanes, traffic, volume, and type. Trucks are going to do a different impact on a roadway than a motorcycle or a vehicle, regular car vehicle. Importance of that segment to the community. Identify where that segment road begins and where it ends. Each segment road should have its a singular identification number. We call it a RIN, road identification number. And a road segment. If there's multiple segments on that road, each segment should have an individual number so you can identify which one it is. Other attributes, maybe the DOT ID number If you have a history of it, you definitely want to maintain that and try to keep up with that. Any previous repairs or maintenance. That can also be useful when you're making decisions. Maybe you can look back and say, well, we've done that 5 times. It still doesn't work. Maybe it's trying to try something else. Some of the physical attributes like length and width, that's going to help develop surface area. So you can allow yourself the development of some repair estimates. Traffic and importance are used to help prioritize when you're trying to decide which roads. High traffic or heavy traffic and high importance areas are going to be a higher priority because of that importance. The conditions, once you know what you have and what you're responsible for, you need to know what the condition each of those segments are. So knowing the condition each section will help identify where the problems are within that network. It'll also allow you to compare those road segments within the agency relative to each other to determine where the repairs should be focused. Again, looking to get the biggest benefit for the network and the community. Process will help identify the types of distresses in each segment. And there are a multitude of different types of distresses out there. Functional conditions such as roughness and skid resistance are also considered. Structural consistence related with the structure of the pavement itself. And all the stresses should be evaluated. Again, we've got a variety of different things on there. Some of the stresses are kind of go hand in hand with other ones. But depending on the surface type, whether it's gravel or paved, the stresses are used to evaluate. Some of the stresses we use basically to evaluate include the drainage efficiency, how well the water on and around the road goes away, longitudinal transverse cracking, alligator cracking or fatigue cracking, edge cracking, potholes, rutting, bleeding, and raveling. Each of these conditions are due to specific types of failures. So if you can identify what your distresses are, it's going to help you determine what the repairs is necessary. You say, well, that's kind of a little bit overwhelming, but there are options here. The Federal Highway puts out a distress identification manual for evaluating cracks and tells you what the causes of them are, tells you how to rate them, provide numbers to them. And it goes into, it's got concrete, it's got asphalt, it's got a variety of different things in there. But it's very useful, pretty informative. And if you haven't got access to that, there's always the option to get a better understanding of what's going on by taking a pavement maintenance course. This actually goes through a lot of those pavement distresses, pavement repairs, causes, gives you an idea on how to maintain your pavements. So a useful course there. Both of these manuals are available on that link, the handout. So if you can just click on the link and download those documents if you need them. Assigning repairs. Again, once you know what types of distresses are present, closer look can help identify the possible causes of each of those distresses. Whether it be load related or material installation failures, maybe failures due to environmental factors. Understanding the cause can help determine a proper repair. And again, you want to fix the issue that's causing the distress. The greater the impact the proper repair can have on the long-term sustainability of that road segment. Load related distresses can be improved with greater depth of support, either in the base or on the surface. Material failures and installation failures may need to be removed, but other practices may be able to correct them to a degree. Again, really depends on the distress itself, the situation you're in. Environmental issues, typically caused by excess moisture, can be addressed to reduce the impacts of a soft subbase or the deterioration of existing material. Again, each distress has specific causes. So again, once identifying the distresses and looking at each situation, you can select the proper repair for each situation. And again, you want to try to fix the cause and not the symptoms. Part of setting a priority is part of the evaluation process of necessary repairs. You need to have some sort of priority. You got to determine which road needs to come first. And if you'll note, this is a simple formula. This is one we use for our software. Basically, it's the priority equals traffic, again, traffic volumes and traffic types, plus the condition, whether the condition is good, fair, or poor. Assessment will give you that. The roughness, is it good, bad, or ugly? And then the importance, again, the importance of that stretch of roadway, road segment, road piece to the community. A road going to the school or road going to the hospital is going to have higher priority, higher importance, essentially, than a road, a dead end cul-de-sac. And then there's the strategy. And the strategy typically is whether it's routine maintenance, corrective maintenance, preventive maintenance, maybe an overlay, rehabilitation, reconstruction, and that strategy is going to drive a lot of it. Again, your focus, what we encourage is focusing on good roads, maintaining good roads in good condition. So that strategy, the strategy of a rehabilitation or reconstruction is going to be lower than the strategy value for, say, a corrective maintenance or preventive maintenance. So that's going to drive a lot on the priority because you're multiplying that strategy by everything else. If you'll note, it does not include cost comparisons. If you wanted to compare conditions and road segments to each other, not based on the cost, that you'll do later. Doesn't include any future deterioration. It becomes extremely complex and a little bit out of hand for most of us. And it's easy to modify. So again, the idea is keep it simple. So part of the implementation, once the road segment has been prioritized, cost estimates can be applied to each repair. Typically done in unit costs, based on a specific unit, whether it's square foot or square yards. Each road segment needing that specific repair can be calculated. So you're going to develop a unit cost, then multiply it by that square surface, that square yards or square foot surface. And that's going to give you a generalized cost on what that repair is going to cost, what that general repair on that road section is going to cost. So several things that go through there. Again, by putting those together, you're going to determine which roads go first based on how was that done? Let's see. Is it but this a lot of times setting up that schedule is based on what's available funds an agency has, selecting the higher priority roads and going down and adding up the cost of those priority roads until you reach the available funding constitutes the first year, and then you go again follow down through the next prioritized roads till you gobble up that available funding for the second year. And you repeat that for the third year and the fourth year. And that's just a general way of doing it. Obviously, these are just tools. They aren't set in stone. You must. So they're just guides, but it gives you a pretty good idea which roads are more important that should be maintained and which you should focus on. Which you should focus on as far as first versus the last. The plan itself is based on priority values. As I mentioned, you're taking those priorities that come up based on that equation from before. And the whole program is based on, as I mentioned, the available funding maintenance funding that's available for each agency. Another part of the process is getting the work done. If the work isn't done, the entire process has been kind of a waste. But as part of the process, once you've got a documented information, conditions, repair needs, repair costs, it's going to help you communicate with the board what needs to be done. It can often, a lot of times, communicating what you want to do with the board is difficult with a difficult board. And sometimes it's not. Sometimes you have good boards out there as well. But having that documentation, having the objective process in the evaluation often helps buy-in. It's a little easier. It's not you up there saying, I want to do this. This is what the program's recommending. This is what we want to do. And this is why, and this is what it's going to cost. It's much easier for them to understand. Again, scheduling the work, knowing previously, well, as we mentioned earlier, knowing what you have and knowing what the plan is going to help facilitate the work, particularly with contractors. So you can work with their schedule. Can you want to schedule early? Have a plan in place. If you can get them lined up, the earlier in the summer, the better. What you don't want to do is wait till the end of the summer to try to schedule work for the current summer. Weather factors can severely change the scheduling, as we saw last year with all that rain. If you wait too long performing work in the cold, can severely reduce the benefits and the survivability of a pavement. Once the work season has been done, you want to go back, updating those priorities, documenting the work that's been done, and again, reevaluating everything. And that's going to help you do some planning and scheduling for the following work year. Again, once for true success, this pavement management systems aren't a one and done thing. They show the success over time. It's not going to happen 1 year, 4 years, 5 years. You're going to see improvements after 5 to 10 years, but it's really a long-term thing. You got to bring all those roads up to good condition and then to get to a point where you're just maintaining them. So it's a necessary for true success. True success, you're going to need to update those unit costs as you go, as time goes through. You're going to need to update unit cost, basically, because as we know, material costs change, fuel goes up, things go ridiculously expensive. So we need to up those costs. That way you have a better idea how much you can get done in an annual year. And you want to keep the evaluations up to date. So in the Northeast, weather can change the condition of a road overnight. So waiting too long between evaluations can lead those roads to failing, particularly if they weren't anticipated. And what we typically recommend is a minimum 3 to 5 years between evaluations. You can do them more often. Larger road, some of the larger agencies that have a lot of roads tend to break them into 1 or 2, sometimes even 3 years, doing a third of the evaluation each year, and then starting over after that in that 4th year. So again, whatever works for you is really the most important thing, but keeping them up to date is definitely important. All right, we've got a PDH question coming up. Are you with us, Amanda? PDH question, specifically, who uses pavement management systems? And select one. Anyone who maintains a pavement network, towns, counties, and no one. So I guess we'll see how this is going. I can't see
about 71%. Say, I'll show you guys now.
Yeah, anyone. Towns and counties do it. And that is, I guess, specific. That was kind of maybe a misleading question, but everybody is correct. But typically anybody who maintains a pavement network has a pavement management system, as basic as it might be. All right, we'll move on to the next question. Where'd I go? Yep, anyone. Which is correct? A network level pavement management systems provide detailed analysis of a specific road identified for repair. B, a network level pavement management system help determine design requirements and specifications. And C, network level pavement management systems help determine the overall needs of a roadway system. That's pretty straightforward, but we'll give it a little bit of time. I guess, yeah, you got to make the call, Amanda. I can't see anything that's going on that polling.
I'll give him a few more seconds.
All right. Yeah, it would be C. The upper two, those are project levels where you do a detailed analysis of each specific road identified for repair. You're going to break it down, find out what you need. Again, that for second level, determine design requirements and develop specifications. Again, you're going to have to look at it a little bit more in depth. Again, the network is just a generalized overview to help you get a better idea of what's happening. This thing stops on me here. All right, and we'll keep moving. So when it comes to funding and dealing with a lot of the stuff that the pavement, those who deal with pavement planning and managing and budgets, common questions you might get from electric officials are basically, do we have enough money? Well, typically that's a no in most cases. How much can we cut from the budget? Ideally none, but they're always looking somewhere. Can we defer pavement maintenance? You definitely don't want to, because the longer you defer it, the worse condition it gets. Once it reaches that rehabilitation reconstruction area, prices escalate substantially. Then the big question, what repair should we do on this road? And it really depends. You want to let the road tell you what its needs are, not necessarily just pick something out of a hat. And you want to fix the issue and not the symptom. And there are, as far as implementation go, there are roadblocks, obviously. If you've got a huge road network, as I mentioned, some of them have so many, they do break them into thirds or cut them in half as far as evaluations. But a large road network can be overwhelming a bit. Sometimes it may take additional manpower. Size of the maintenance needs. Maybe you need more maintenance than you can actually possibly consider. And that'll stymie it a little bit. Again, you got to start somewhere. You just don't want to quit. Complexity of the maintenance needs. If your roads are in really poor shape, they're going to require a lot of complex work and things to bring them up to snuff. And it's going to take a lot longer to get there. But again, you need to start somewhere. Decision makers' experience. Whoever's deciding on repairs to do, if they don't really understand what a reconstruction is and they do an overlay, they may fix the road for a little while, but you're just buying time. That road will fall apart again. If you don't fix the stresses below, they come back. And other personnel commitments. Again, if you've got a small shop, you've got 3 or 4 people on staff, sometimes it's difficult to get out there and do your road evaluations and assessments and come up with an inventory and that kind of stuff. So it's there are some issues as far as implementation goes. But again, we've got solutions for that too. But anyway, we'll keep moving. What you really want to do if you are maintaining your roads, responsible for the maintenance of your roads, what you want to do is try to seek out a champion. Try to find somebody or several people on the board that are willing to come out and see what you do, see what the roads you cover, see what issues you got to deal with. Get them to understand where you're coming from. And again, get their support behind you, get them involved. Another means is basically demonstrate what the network needs are. We're going to talk a little bit about that. So again, if you want to develop an annualized cost, basically try to figure out how much it's going to cost on an annual basis. You need that inventory, you got to complete that. Calculate life cycle of each item. Determine annual cost. Sum the total together, and then so from there you'll get your annual cost. And it's seems easy, but it's a little bit more in depth, and we'll go into an example here. This example is essentially from Steuben County, based on one of their spreadsheets here. This is a spreadsheet of different types of roads that they've got there. You can see road type, treatment years, miles, number of treatments, years, essentially life expectancy for each of those road segments. Then you've got miles per year repair per method. So you got crack seal, chip seal, slurry seal, you've got grinding, you got 10-inch base with gravel. With fabric, you got 1.5-inch hot mix, you got recycle, seal, recycle and hot mix, and then the fabric with 15 inches gravel. So what they've decided that they were doing this year, this is the minimum 2009 money needed, so the prices are probably off. But they've got several types of roads. They've got a blacktop with a good base, they've got a chip seal with a fair to good base, chip seal with a bad base, a cold mix with a good base, and a cold mix with a bad base. These are the road types they've got. So for each of these types of roads, they've got 290 miles at the back blacktop good base, 89 at this other one, 35, 139 of cold mix good base, and then 125 of cold mix bad base. That's their total miles. Here is the life expectancy: 20 years, 17 years, 45, 20, 45. So what they've done is basically mapped out what they're going to be doing. They'll start with a recycle. Basically, they're going to redo the road in the year 1. They're going to follow up in year 4 with a crack seal. Year 9, they'll put a slurry seal down, again, come back 7 years later, put year 16, put another slurry seal down, and it goes another 6 years, and that's their life expectancy. Then they'll recycle again, start to do it again. The chip seal, again, they follow the same practice. Grind it and get a good surface to it, and then chip seal on year 2, 7, and 12. And then that following 5 years will basically give you the 17 to life. So it kind of follows through each of these processes. But what they do here is they have crack seal. They do a crack seal once. That's what this indicates. They do slurry seal twice. Here they do a reconstruction or a rehabilitation in year 1. Then they do 3 successive chip seals. And that's what this column actually indicates. And they're going to use that later for other purposes. And I'll show you that coming up. What it does is it calculates for how much they're going to do each year. They want to do 14.5 miles a year. So they just round up to 15. They use the unit cost to come up with a guesstimate on what that's going to cost. The chip seal, and they're doing 3 here. And so they're planning on doing 15.7 miles. Again, they're doing it twice here, that 13.9. So essentially 30 in the area of 30 miles, and at $14,000 per mile, they'll come up with a cost. And they do it for each of these different types of practices. This budget year, they're actually not doing the 1.5-inch hot mix or a recycling slurry seal, or this 15-inch gravel with fabric. So what they end up doing is they come up with unit costs. They have their unit costs. They determine how many miles they're going to be doing each year. They come up with a total cost they're going to need to achieve that. And this is what they end up being here. Down here is their total cost. So they've got a total cost estimate of what they want to do, about just under $5.9 million. They've got a budget of 5.3, so they're identifying their financial need essentially of approximately $564,000. So that's their deficit. So now this is something you can explain to the board and work with the board. You've got the numbers all set up based on how you've calculated. You can share that with them. Then they identify what their first priorities are. 1.3 million, essentially minimum needed for chip seals, slurry seals, and crack seals. Again, their goal is to keep good roads good. $1 not spent becomes $6 in 5 to 10 years. Oops, there you go. Minimum needed to grind chip and paver patch on very bad roads and an emergency is another just under 500,000. Then the second priority is minimum need for construction and pavement, which is about 4 million. So it's basically something they can share with their board. It identifies what their needs, it identifies what their deficiencies are, identifies the plan. Again, getting all that on paper and documented, it makes it a lot easier to discuss over time. And this approach can actually be used for all of your assets, or pretty much all of your assets. Obviously roads, but bridges and culverts, signs, guide rail, equipment, miscellaneous items. Again, determining what you're going to need out of it and being able to budget for it each year. Again, what they did was probably they defined road race structural types. Each one's going to have a different strength, different design. So we're going to use as an example high volume roads that have trucks, but other options maybe the downtown commercial areas or residential. Each one's going to need a little bit different type of design. So using those numbers from before, we got a high volume road with trucks on it. Again, we're developing an average cyclic plan here. The cycle life is approximately 35 years. That's what they're using. So these are the treatment years for each of the repairs are going to be. They got crack repairs in year 5, patching year 6, wearing course 7, crack repairs again in year 9, overlay in year 10, crack repairs in 15. You can see the years are basically, well, they go 1 year, 1 year, 2 years, And then they go through an overlay in year 10, so 1 year, and then they go back 5 years. And at the same time doing crack repairs and patching. Then they put a wearing course over it, and they can recycle the surface and go back. Again, that's their cyclic maintenance plan over that 35 years. And again, from that, you can actually put costs to that. So you want to calculate how many miles per year per treatment. The equation for that is how many miles you got by street type. Again, we're talking about trucks with roads with heavy trucks. What's your cycle length? Again, 35 years. And then the number of treatments per that time, and then multiply it by the number of treatments during that life cycle of that road. So what they've done here, again, high volume with trucks, they've got 30 miles with a 30-year cycle. So essentially what they've done is for those roads, you've got 5 crack seals, average of 4.3 miles a year, patching 3.4, wearing course 3 times, overlay 2 times, recycle surface 1 time, reconstruction 1 time. And it's miles per year. Basically, they're breaking it over that 35-year period. So essentially from that, then you can add together all the repairs and use this to determine your annual needs, your appropriations. So again, you're determining what the cost per year is. And then from here, you're summing up the cost per mile and then the number of miles per year. And that's done in this table here. So you've got the treatment cycles, miles per year, and then you've got a unit price for each of these costs, and you're multiplying it. The unit cost times 4.3 and coming up with 30,000 a year. Patching, you're doing 4 times that unit cost 17, and it kind of goes down, multiplying the cost. It determines for that road type, they're going to need $522,000 a year to maintain that road type on an annual basis for essentially an estimated 35 years for that life cycle of that road. So this is what the annual funding is necessary that they're going to need. So as I mentioned, there's other assets. While there's multiple different types of software out there that can help an agency, we offer this Cornell Asset Management Plan. Basically, it's a program that's available pretty much to anyone. It is a snapshot. It doesn't do any kind of predictive what's going to happen in the future. It's just, it evaluates what the roads are now. Again, they could change with a heavy storm. But again, it collects the inventory, condition assessments. You can assign repairs within it. You can diagnose the entire network based on those repairs and the needs of it. And then develop a plan based on that simple formula that we showed earlier. The software is available to anybody that's interested. Just call us and it's available for $90, I believe that's the cost. Another option is our summer intern program. If you've got an agency that's a little short on manpower, but still would like to get into something like this. We have a summer intern program where the intern essentially works for the municipality. It's a 10-week program. We provide training. This year, the training will be on May 23rd to the 25th. It's held at Cornell. And then over the course of the 10 weeks that summer, we'll provide technical assistance training. We'll do site visits, all kinds of things, and we're available for phone calls and emails, and essentially to provide that support during the training to support both the agency and the intern. And after that, we continue that support. So if you come back and the student did it one summer, you come back that next spring to try to figure out where you are and what you need to go. If you don't have, if you didn't really get a lot of time on it and you're not familiar with it, let us know. We'll come out and show you again. It's, we're here to support you guys. But again, that's the intern program is pretty valuable. It goes pretty well received. It's open to any agency. Typically, we do a maximum of 18 agencies per year. It's on a first come, first serve basis. So if you're interested, talk to your board, let us know. And in this case, basically, the student develops that maintenance plan that does all the they gather the inventory, verify the inventory, do the assessments, the evaluations, come up with cost estimates, work with the highway superintendent or DPW supervisor, and whoever's in charge of the maintenance of the road, to develop a plan based on the priority equations and the recommendations. Again, the students are summer employees, so they work for you, but we help support them. And as I mentioned, let us know by the end of February, 1st of March. And there's information if you need it. I believe this is also on the handout. It may not be, but and anyway, moving along, let me know if you have any questions. Just reach out to me and we'll go from there. But with any of these pavement management plans, like as I mentioned, they don't happen overnight. You got to think long term, and you got to be flexible. You could plan for the best plan for the next 5 years, and the year 3, major floods happen and wipe out roads, and there goes your budget. You need to be flexible. You can adjust these things. Again, these are tools and guides to help better manage, and they're not you must do this kind of approach. So just kind of go through review. There are multiple benefits you can get by implementing a pavement management plan. Again, as we mentioned this a few times today, is efficient use of limited resources. Again, you want to get the best bang for your buck with your limited available funding that you have. You've got documented results, an objective evaluation, so you can actually substantiate the results that you're finding. Again, it's all based on preset parameters. There's no I want this, I want that in it. Helps you determine the conditions of your road. That gives you a better idea on where you stand and what you need to focus on. Having all this information, have that documentation, being able to substantiate your results is going to provide better communication with the board, but not only the board, but also the public. We've had participants that have called the town that have said of our camp program that have called the town, and the students have put together reports. They've put the reports right on their website. So when people complain or want to know when their road's getting done, they just send them to the report and say, this is how it is. So at least having a plan is going to help better communicate to the community. By updating it and maintaining it, you're going to have better information on what your network is, the needs of the network, the costs that you have. And again, because you have that substantiated results, you know what your conditions are, you're going to get better cooperation, not only from the board, but if you're looking for funding, it's going to go a long way when you ask for a grant or some sort of funding source from whether it's the state or the federal government. If you've got a plan and you can identify where you're going to spend that money, your requests are going to rise to the top over somebody who says, I just need $100,000 to do paving. If you have specifics, they're more willing to grant you these additional fundings. So again, looking at the pavement worst first, and we want to try to maintain a good level of service where the road is going to be useful, safe, efficient. So let it go. Again, we preventive maintenance is basically the best way to do it. You're going to do those cheaper costs, the dollar per unit approach, keep those roads and keep them in better condition. Again, keep good roads in good condition, as opposed to letting it fail and then spending a large sum of money. It's 5-6 times that unit per cost per for these approaches. So I guess we'll hit another PDH question. We're getting close to our time if we haven't passed it. Question 3, pavement preservation. Select the incorrect answer. Looks to keep roads good in good condition, or keep good roads in good condition. B, extend the life of existing pavement structure. C, improve the overall quality of the network. Or D, is more costly than repairing the worst first. If you've been listening, that should be an easy one.
We're about 50%. We'll give you guys a few more seconds to get those answers in. Remember, it's select the incorrect answer.
Yeah. Yeah, it looks like I might have missed the mark. D is the incorrect answer. I guess I might have missed that as we're going through. Pavement preservation, the goal is to be more cost efficient. It does look to keep good roads in good condition. By doing that, extending the life of the existing pavement, and then by doing that, you're improving the overall quality of that network. Again, the approach is a cost efficient one. The idea is basically you're going to get the best bang of your buck by applying the funding where it needs it based on what the conditions of the road are. All right, we'll move on to the next one. Pavement preservation. No, that didn't help. Doesn't work. There we are. All right, number 4, which is not a benefit, again, not a benefit of pavement management. A, efficient use of limited resources. B, provide more accurate information on conditions of the network. C, better communication with the board and public. D, allows one to substantiate results and decisions. And E, provide details of each project. Again, which is not a benefit. I should better word these questions, I guess.
You guys, a few more seconds to get those answers in. While that's going on, thank you, Jeff, for presenting today, and thank you guys for joining us. We are off next week as the town, I believe it's the winter meeting for the towns or the counties. But we will be back on the 24th.
Yeah, again, the answer for that is, which is not a benefit, providing details of each project, that then you enter into the project level. A benefit is efficient use of limited resources. Having all that documentation and the information allows you to communicate better with the board and the public. And it does allow you to substantiate your results and decisions based on that documentation and information. So that essentially the answer on that one is E. It doesn't go into the details. All right. And that'll be it for today. I kept you a little bit longer, I guess. I apologize for that, but thank you for attending. If you have questions, let me know. If you're interested in the intern program, reach out to me or reach out to the Barbara at the main office. And we'll work with you to get you involved. Yeah, we are taking names for agencies at this point. By the 1st of March, then we start reaching out to students to try to get those interns lined up as well.
Thank you, Jeff. Thank you guys. Have a great rest of your Tuesday.
All right, thanks.